I start my presentation. The 3D design with the controller in the VR space is popular and accessible to users. The effectiveness of the design system using VR has been verified in previous studies. However, the disadvantages of design in VR space also exist. For example, OpenBrush, a free open-source VR painting application, usually requires the user to physically go around to see the different size of the target object in the VR space. In addition, the design tasks also require great effort such as repeatedly adjusting the object scale to grasp the entire design. To release the burden on user efforts of 3D brush painting design in VR space, this study proposes MultiBrush, a design system that uses multiple viewpoints in VR space. In this study, MultiBrush superimposes the image from a viewpoint opposite the object to be designed, and the bird's eye viewpoint captures the entire object. In addition to the normal viewpoints, we also implemented a function switching opposite viewpoints with the VR controller's button to reduce the moving burden. We surveyed related studies from two perspectives, designing in VR and multiple viewpoints in VR. Clear VR proposed an accurate perception of VR space by making blueprints visible from all angles. Adaptive Brush developed a system that accurately predicts the ribbon shape produced by hand movements to reduce the burden of rotating the wrist when drawing 3D shapes. Surface Brush proposed a new approach to modeling 3D shapes that transforms VR drawing into the 3D surface intended by the user. HxAI-LAB constructed a system that overlaps multiple viewpoints in VR space and simultaneously recognizes multiple remote locations by switching between transparent and opaque views, thereby creating interaction in VR space. Multisoma split the screen to display each viewpoint of synchronized avatars in VR space. Please see the figure on the left. In contrast to the conventional single first-person viewpoint for the proposed system, the opposite viewpoint is displayed in the upper left corner, and the bird's eye viewpoint is displayed in the upper right corner. By presenting the opposite viewpoint, users can grasp the design by viewing the design object from multiple perspectives, and quickly move to the opposite viewpoint that reduces the burden on the user. Please see the figure on the right. For the proposed multi-brush system, we set multiple cameras installed in the VR space to realize the multiple viewpoint technique. The conventional first-person viewpoint and the proposed system are explained using video. The video on the left shows the conventional first-person viewpoint system. The video on the right shows the proposed multi-viewpoint system. The letter A is displayed in front of the normal viewpoint, and the letter V is displayed in front of the viewpoint from the opposite side. In addition, an avatar is displayed in the opposite or bird's eye viewpoint cameras. The system framework is shown. The inputs of the system are the user's body movements and the controller's button entry. If the user moves, it is reflected in the VR space. The controller button entry is also used for the four functions of system processing. The output of the system is to design objects in VR space using these functions. For example, the user can decorate the predefined object by drawing lines using the VR controller in the VR space. To implement the multi-brush prototype system, MetaQuest 2 and Unity were used to create a VR environment that allowed designing with a pen and eraser tools in the VR space. Avatars were created using Meta Avatars SDK. The right-hand controller is used as a pen tool, and lines are drawn in the VR space when the right hand controller is moved while a specific button is pressed. The left hand controller is used as an eraser, and when the eraser encounters a line drawn in VR space, the line disappears. There are two types of line colors, red and yellow, which can be switched by pressing a button on the left-hand controller. Pressing a button on the right-hand controller instantly switches to the opposite viewpoint, reducing the user's physical movement effort. To return to the viewpoint, the user needs to press the same button again. In this study, we conducted a comparison experiment in which the design was conducted from both the conventional first-person viewpoint and the proposed multi-viewpoints of MultiBrush. The subjects in the experiment were 8 male graduate students around 20-year-olds. Experiment details. 1. To familiarize the subject with the system, we first taught them how to operate the pen and eraser while wearing the head-mount display, and then had them experience the normal first-person viewpoint system for about 5 minutes. 2. After the subject familiarized themselves with the pen and eraser operations, we switched to the multiple viewpoint system, explaining how to switch viewpoints and how to see the screen. 3. After having the subject perform the normal first-person viewpoint design for a period of 5 minutes, they were also asked to perform the multiple viewpoints design for a period of 5 minutes. 4. They were then asked to complete a questionnaire. After the experiment, the subjects answered 9 questions. Left figure shows the design results of conventional approach by single-person viewpoint, and right figure shows design results of the proposed multiple viewpoints with the same subject. The result of conventional first-person design shows that some parts of the design are undecorated. On the other hand, the result of design from multiple viewpoints shows no area with no decoration. Designing with multiple viewpoints may prevent lack of design because objects can be viewed from different angles. The video on the left shows the subject during the experiment. The average number of viewpoint switching was 7. The average multi-view design time was approximately 243 seconds. The results indicate that subjects switch viewpoints approximately once every 35 seconds. Green indicates a positive response to the question. Red indicates a negative response to the question. The horizontal axis shows the percentage of positive or negative responses. We observed that the most of the subjects did not have much experience with VR and design. Regarding question C, the subjects were divided into 2 groups, those who felt that the body movement was reduced and those who felt it was not. This may be because some subjects found it burdensome that after switching viewpoints, they had to walk the location they wanted to design. Regarding question D, 7 out of 8 subjects answered either strongly agree or agree. This is thought to indicate that the bird's eye viewpoint helped the subject understand the design. Regarding question E, the subjects were divided into 2 groups, those who felt stressed and those who did not. It is believed that the subject felt stress when viewing multiple screens in a multiple viewpoint system. Regarding question F, 7 out of 8 subjects should strongly agree or agree, indicating that the system was easy to understand. Regarding question G, 7 out of 8 subjects answered strongly agree or agree, while 1 subject answered disagree. This may be because there were many physical buttons, such as a button to draw lines, change the viewpoint, and change the color. Regarding question H, the system was well received by all subjects. Regarding question I, most of the subjects were generally satisfied with the system. Subject positive comments. I felt that my designing ability was improved by performing the operation from multiple viewpoints. I also felt that it improved the diversity of my design. By looking from the bird's eye viewpoint, I could understand how I had designed and could easily visualize what kind of design I wanted to create. It was easy to see the whole picture from multiple viewpoints, so it was easy to find out where the design was lacking. I didn't feel as much danger because I didn't have to move around as much. I was happy to be able to see myself designing from multiple viewpoints. It was fun for me to see my avatar designing. Subject negative comments. When I changed the color, I couldn't tell which color I was using. I was not particularly aware of the bird's eye viewpoint. I think the effectiveness of the system will be felt as its accuracy improves. The layout of the bird's eye viewpoint is not good. It is difficult to design in a VR space. It may become easier to use multiple viewpoints when I get used to it. In this study, we propose MultiBrush, a 3D brush painting method that uses multiple viewpoints in a VR space. We compared our proposed method with the conventional first-person viewpoint through experiments. From the result of the questionnaire, we confirmed the advantages and disadvantages of the design method using multiple viewpoints. Through the evaluation experiment, some subjects experienced positive effects that we did not expect, such as improvements in their design skills and present feeling. This opinion is very interesting and needs to be verified in the future. Future work may include some improvement to the current prototype system. In addition to the conventional first-person viewpoint, the current system displays the opposite and bird's eye viewpoints in the upper left and upper right corner of the screen, but it needs to be made more visible to users. It is also promising to add a button to enable or disable the multiple viewpoints function, which can allow the user to enable the multiple viewpoints function only when they want to use it in their design.